Welcome to Homework Lib.
Hi, so for this question we have in both of the cases 1000 grams. So let's calculate the amount of mole of magnesium, first of all, that we have. This is going to be the mass of magnesium divided by the molar mass, right? So mass divided by molar mass or molecular weight, whichever one you prefer or you're using. So in case for magnesium directly, the molar mass corresponds to 24.3 grams per mole. So in magnesium, what we get is 41.15 moles. 41.15 moles of Mg. Okay. Next up, what we are going to have is calculating the amount of mole of iron oxide. The procedure is the same, but now the molar mass changes. The molar mass of iron oxide is 159.69 grams per mole. So this is going to be 6.26 of iron oxide. So now our balanced reaction that we have is that 3 equivalents of magnesium plus 1 equivalent of iron oxide is going to react to generate 3 equivalents of iron plus 3 equivalents of magnesium oxide, right? This is a redox reaction. So in order to know the limiting reagent, we have two ways. We know that there is a 3-to-1 relationship. So this amount of mole of magnesium correspond to a maximum amount of 13.72 moles of iron oxide. And we can do the same thing with the iron. So this amount of iron can react with up to 18.78 of magnesium. So that is the maximal amount of mole of each one that we can have for reaction. And clearly you can see that the amount of magnesium can react with much more iron than what we have. So magnesium, it will be the excess reagent with 41.15 moles, and iron oxide, it is going to be my limiting reagent with 6.26 mole that can react with a maximum amount, considering a 100% yield, of 18.78 mole of magnesium. Okay? So the limiting reagent is iron oxide. We know magnesium is going to be in excess, so how much is going to remain? So how much remains of magnesium? It is going to be the amount of mole of magnesium that we have minus the amount of mole of magnesium that reacts. This is going to be 41.15 minus this 18.78 that we have. So we end up with 22.37 mole of magnesium left after the reaction. Now, usually that amount you need to convert it to mass of magnesium left using the molar mass again, right? So we have 22.37 moles of Mg of magnesium, and the molar mass, we have it over here, is 24.3 grams per mole. So we simply need to multiply it directly. So the final amount that we're going to have left is 543.591 grams of magnesium. We can have the answer in mole and in grams. It depends on your professor or what was asked in that specific question. So that would be all.